Okay, class, today we're going to learn how to solve a quadratic equation in vertex form. So here's our equation. Right now you can see it is in vertex form. There's a vertex at 1, negative 27, and there's a vertical stretch. It's obviously opening up with a vertex of a minimum. So the very first thing we want to do here to solve this is we want to set the equation equal to 0. Why do we want to do that? Well, just remember that the roots are found where the graph crosses the x-axis. So when we solve, we're looking for the roots. When we solve, we're looking for the roots. Okay? So since the roots are on the x-axis, we need to set y equal to 0. So that's why we set the equation equal to 0, because that is where the roots are located, on the x-axis. Okay, so we're going to make this into a 0. So I'm going to switch the equation around. I just prefer to go this direction. You don't have to. And we're going to go ahead and solve. So remember, when solving, we undo GEMDOS backwards. So we start by undoing, adding, and subtracting. So to isolate the variable x, we're going to add the 27. Remember, what you do to one side, you do to the other side. Then we're going to undo multiplying and dividing. So since we have multiplying here, we're going to divide to cancel that out. Next thing we're going to do is we want to cancel out the exponent. So to cancel out a square, there's two different methods for canceling out an exponent. So since this is a square, we could square root both sides, or we could raise this to the reciprocal power. So if we're going to square root, we would make a square root symbol on each side. That will cancel out the square. Now, because there are two roots for a quadratic equation, even if it is the same root, there's always two roots, okay, when there are real x-intercepts, real roots, okay? And I use that word real because we're going to see what happens, what are the solutions when it doesn't cross the x-axis. Right now we're just dealing with roots that exist on the x-axis, okay? So since there are two, when you take the square root of this number here, you're going to tack on a plus and a minus, or a positive and a negative on that answer. When solving, okay, you need to, when you take the square root, you want to put that positive and negative on the front of that answer there, okay? Now back to this deal here. Another way to cancel out an exponent, and this is very important to learn, is to raise it to the reciprocal. The reciprocal of 2 is 1/2. This is going to come in handy when we have rational exponents, fractions, if you will. Okay? So if we were to use this method, we'd raise it to the 1/2 power, and we would raise the 9 to the 1/2 power. So remember from Algebra 1 that when you have a power raised to a power, you multiply. So 2 times 1/2 is 1. And 9 to the 1/2 power, well, the top number represents the power, and the bottom number represents the root. Well, 9 to the first power is just 9. And the square root of 9 is 3. Don't forget the plus and the minus. Okay, so continuing on to solve for x, we're going to add 1 on both sides. Now here's where you're going to get your two answers. So the first, you're going to take the positive 3 and add 1 to get your first answer. And then the second root is found by taking the negative 3 plus 1. And that's how you get the negative root. So there are your two roots. Now when you're solving, it's okay to leave your answer in this format. You don't have to put it in point form. But if for some reason I asked you for the x-intercepts, then of course you would write it in point form. But when you're solving, this is fine. Okay, let's look at another example. And by the way, when you get numbers that look like these are called rational numbers. And it's important that you understand different types of numbers. Rational numbers are numbers that can be put into fraction form. Well, I can put both of these over 1 and they're in fraction form, so they're rational. Okay, let's take a look at another example. I'm going to start off right away setting it equal to 0. And we're going to go ahead and just solve this. Adding 28 on both sides. Dividing by 2. And canceling out the square. Since this is an advanced math class, we're going to go ahead and just do the reciprocal power on both sides, because that is a more advanced move than just putting the radical over the top. So 2 times a half cancels. 14 to the first power is 14, and then we're taking the square root of 14. Well, that's not a perfect square, and it cannot be simplified. So we're going to write, but don't forget the plus and the minus, positive and the negative, square root of 14. Finally, we're going to isolate that x by taking care of that 1. So here are our two solutions. It's going to be positive and negative square root of 14 plus 1. And this is an irrational number. Actually numbers, because your two numbers are the square root of 14 plus 1 and the negative square root of 14 plus 1. Those are our two solutions. And they're irrational because the square root of 14 cannot be put into fraction form. And no, you can't just put it over 1. Okay, this is going to be a decimal that does not repeat and does not terminate. So it is irrational. So anytime you have a radical in your answer, I'm going to tell you right now that it's going to be irrational, as long as it's not a perfect square. See back up here, 9 was a perfect square. The square root of 9 became 3. That's a rational number because that's a perfect square. Okay, one more example. All right, so solving for x. Go ahead and start. Divide by the negative 1 out front. taking care of our exponent by raising it to the reciprocal power. 2 times 1/2 cancels out. Negative 16 to the first power is negative 16. And then we're going to do the square root of negative 16. All right, so from yesterday's lesson, we know that, first of all, don't forget the positive and the negative on the front, that we need to break this apart to simplify it. So it's going to be negative 1 times 16. So I'm going to go ahead and simplify this right now before I finish solving. You could finish solving first and then simplify it. It's fine. So we're going to have the square root of 16, which is 4, and the square root of negative 1, which is I. Notice the positive and negative come straight down. Okay, so our two solutions are 4i, positive 4i minus 4, and negative 4i minus 4. And these are not rational, nor are they irrational. They're complex numbers. We learned about this yesterday. Remember, because it has a real part and an imaginary part. And this is the kind of example where the parabola does not cross the x-axis. So this one may look, if I was to draw a little sketch here, we got a vertex of negative 4, negative 16. So our vertex is down here somewhere. Negative 4, negative 16. Okay, and it opens down. So notice that it doesn't cross the x-axis. So when it doesn't cross the x-axis, we have complex solutions, and they're going to involve an imaginary part. All right, well, that's a lot of information. I'll see you in class tomorrow. Bring your questions.